guys, it's Mr. Wickeser here. Today I'm out, so I'm making a video lesson of Chapter 2.7, Absolute Value Functions and Graphs. So let's start with what absolute value actually is. Remember, absolute value is a distance in numbers from 0. So usually it looks like this. What is the absolute value of 5? Right, the number 5 is 5 from 0, right? And what is the absolute value of -5? And so you're going to have to do both these to figure out what absolute value actually is. And -5 and 5 are both going to be, answer is 5. It's a distance in numbers from 0. So let's look at a line here. A terrible line I just drew. So in the middle, you have 0. Then over here, you have 5 and -5. And if you look, if you count, both of these are 5 units from 0, right? Here's 4, 3, 2, 1, -1, -2, -3, -4. So they're both 5 units from 0. So now we're going to graph those. And you can use Desmos to graph. Before we do that, we're going to look into see how you solve each absolute value expression, just to review a little bit. So let's do it in the parentheses first. 5 minus 7 is -2. -2 times 3 is the absolute value of -6. Right? And you should be able to solve that without using anything. And that'll be 6. And this one's a little trickier here. You have the absolute value of -8. And absolute value of -8 is just 8. But you have the negative on the outside. So the answer is going to be -8. So the absolute value of -8, I said, is 8. Then you take that and put a negative in front of the 8. Number 3, you have the absolute value of 4 minus the absolute value of 9. It's basically 4 minus 9, and the answer is going to be -5. So you guys should know that. Here's a trickier one. You have the absolute value of 5 minus the absolute value of 2. So 2 minus 5 is -3. Absolute value of all of that is just 3, right? So here we go. Symmetry. Axis of symmetry, symmetrical and symmetric. Definition. Symmetry is a correspondence in size, shape, and relative position of parts of opposite sides of an axis of symmetry. So the graph of y equals x, and I want you guys all right here, is a mirror image of itself over its axis of symmetry. So this is what we do for this. You're going to go in here and you type in your computers. You can push pause on this now if you want to. But you're going to type in your computer's Desmos, right? And you have the little app down here, I realize that. But we're just going to graph y equals absolute value of x. And this is our parent function we talked about the other day. You start at 0 in the middle, and you go 1 up, 1 over, and you can't see that because it's not zoomed in enough right now. But there it is. 1 up, 1 over on this side, 1 up, 1 over on this side. So it's getting 1 up, 1 over, 1 up, 1 over. And it's all on the x-axis. Y-axis is axis symmetry. And that is a parent function of y equals x, the absolute value of x. So it's going to look like this, like we just said. And there's the y and there's the x-axis. Any questions? Okay. Now we're going to do some absolute symmetry line drawing through all these shapes. So where's a line of symmetry, which means right in the middle of it. My lines are terrible with this program. I apologize. This one right down the middle. Right? This one again, this line of symmetry is right down the middle. Cuts it right in half. Number 7, cross out the graph that does not show symmetry around the y-axis. And so this one, here's y-axis. That one's going to be true. This one's going to be true also. This one will not be true here because you put a line down here. This will reflect over here, and this will reflect over here. So this is not true. So we're going to put an X to that and say you're false. Problem 1, graphing an absolute value function. Like I said before, you can see these, and right here you can see y equals x, absolute value of x plus 2, and you can see how it's different from the parent function. And so, but you can also put them in Desmos like I did before and see y equals absolute value of x plus 2. And you can see the difference here. All it is 2 up on the graph. There's 0, 0, and this one is at 0, 2. And that's the parent function, and that's the plus 2. So over here, we're just going to complete the tables and put them in here. So it's absolute value 5 plus 2. I'm sorry, the absolute value of negative 3 plus 2 is 5. Because 3 plus 2. Absolute value of negative 1 plus 2, which is 1 plus 2 is 3. 0 plus 2 is 2. And this is where you get the situation where you're probably not used to it. Then you start going down, 5, 3, 2. Then once you get to 1, 1 plus 2 is 3 again. So you start going back up. And 3 plus 2 is 5. And you can see the absolute value graph is going to go from here down and back up. And here is 0, 0, and so on. So use a table from exercise 8. Circle the graph of y equals x plus 2. And here's our y equals x plus 2 we just talked about right here. So we're going to take that and circle this one right here. Okay, describe how the graph of y equals x plus 2 differs from the parent function. And again, use Desmos. All you can say is it is translated or slid 2 units up on the y-axis. That's what I would say. So you can write that in there. 2 units up. And this is terrible handwriting in this little program. Let's say it really quick because I can't type so well. On y axis. Okay, key concept. This is the whole translations, and we're going to talk about this more when I get back. But the key part of it is the key concept is the vertical stretch and compression and reflection are big important things. The vertical translation and the horizontal translation are also big ideas, which we're going to talk about a little more. So this little a in front of this will make the stretch bigger or smaller. The negative here is going to reflect it. And also down here, we're going to put an X here. We're going to put a check here. We're going to put a check, 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 and an X. Okay, and so this is the parent function, and here is the one right here, and it's 1/3, which we haven't talked about before. I kind of set it up about a minute ago, is going to be the stretch or the compression. It's a negative 1/3, so it's going to be very, very, very negative. And it's going to go down, which we didn't show you before. And I'll show you that real quick right now on Desmos. Y equals negative 1 divided by 3 absolute value x plus 5 absolute value plus 2. and it's way, you have to scan out a little bit here, but it's a negative right here, which is going to say it's going down. And so it's really, really wide. That 1/3 makes it really, really wide. And it's starting at 5, 2, which really actually means, and this is something that's going to blow your mind here, it actually means a -5 on the X and +2 on the Y. So the H and the K mean, which we'll talk about more in class when I get back, is this is going to be a -5 + 2. So let's go down, talk about vertical stretch and compression a little more before we do our end of the unit activity. And again, you're going to use this as the parent function, and you're just going to plug in these numbers for X. So -2 times 2, which is actually 2 times 2, is going to be 4. And this is going to be 2. And this is going to be 0. And again, that's the axis right there, the apex. Going to go back up to 2 and 4. We're going to graph it here. And it's going to go 2 up, 1 over, 2 up, 1 over to here. So it's going to look like this. Like a V. All these are going to be V's. The question down here, the student compares the graphs of this and 2x. She concludes the graph is compressed. The value of its slope increases. Explain her error. So let's go back and do it on Desmos and show you. And this is the easiest way to compare them. Y equals absolute value of x plus 2. Right there it is. And the other one says y equals absolute value of 2 times absolute value of x. So it's y equals 2 absolute value x. And there's a difference right there. This starts at 2. So plus 2 here means the y-intercept's at 2. And this one starts here. And it's a stretch of 2. So you're going 2 up and 1 over. 2 up, 1 over. So you want to write something in there about that down here in this thing. So I would say the one with right here, I would write down there that it stretch of 2. So it's 2 up, 1 over, right? So it's a little, and then 1 over. The other one starts at 2, right? Right here, and goes 1 up, 1 over every time. So this one is going to be 1 up, 1 over. We can just put 1 over 1 to show that. Okay. 4 and 5 to go. I'm going to stop there for this lesson and show you the next video about that one if I can figure out how to do this here. Maybe not. I'll be able to.